Hi, welcome back to my channel. There are 4 data streaming solutions in AWS. You can run Apache Kafka in AWS EC2. You can choose the AWS native cloud service from Kinesis Data Streams KDS or AWS Managed Streaming for Apache Kafka MSK. You can also choose the enterprise stream data platform Confluent to run the Kafka service in cloud. If you want to check the difference between Kafka and GCP's native cloud service pops up, you can check it in my Google Cloud Pops Up's last minute cheat sheet. Let's compare these data streaming services solutions in the AWS today. Let's take a look at the architecture first. Apache Kafka is an open-source stream processing software platform developed by LinkedIn, donated to the Apache Software Foundation, and written in the Scala and Java. Kafka architecture is made up of topics, producers, consumers, consumer groupers, clusters, brokers, partitions, replicas, leaders, and followers. Kafka cluster consists of one or more Kafka brokers running the Kafka. Producers are processors that push the records into Kafka topics within the broker. A consumer pulls the records of a Kafka topic. Topics are divided into the partitions, and the partitions are replicated across the brokers. Each partition includes one leader replica and 0 or greater follower replicas. Management of the brokers in the cluster is performed by Zoomkeeper. There may be multiple, for example, 3 to 5 Zoomkeepers in a cluster. On the API architecture standpoint, Kafka has 5 core APIs. The Producer API allows applications to send streams of data to topics in the Kafka cluster. The Consumer API allows applications to read streams of data from topics in the Kafka cluster. The Streams API allows transforming streams of data from input topics to output topics. The Collect API allows implementing the collectors that continue pulled from some source system or application into the Kafka or pushed from Kafka into some sink system or application. The Admin Client API allows managing and inspecting topics, brokers, and other Kafka objects. Apache Kafka has the following benefits for real-time streams of data collection and big data real-time analytics. It works with the huge volume of real-time data streams. It handles high throughput for both publishing and subscribing. It has a highly scalable distributed system with no downtime in all 4 dimensions from producers, processors, consumers, and connectors. It handles failures with the masters and the database with the 0 downtime and 0 data loss. It offers provisions for deriving new data streams using the data streams from the producers. It uses distributed commit logs to support messages persisting on disk. It replicas the message across the clusters to support multiple subscribers. As a result, Apache Kafka aims to be scalable, durable, fault-tolerant, and distributed. However, Apache Kafka requires some human support to install and manage the clusters. Also, the extra effort by the user to configure and scale according to the requirements such as high availability, durability, and recovery. Let's take a look at AWS Kinesis. AWS Kinesis has 4 capabilities: Kinesis Video Streams, Kinesis Data Streams, Kinesis Data Hosts, and Kinesis Data Analytics. The Kinesis data streams can collect and process large streams of data records in the real time as same as Apache Kafka. AWS Kinesis offers key capabilities to cost-effectively process streaming data at any scale, along with the flexibility to choose the tools that best suit the requirements of your application. It enables you to process and analyze data as it arrives and responds instantly instead of having to wait until all your data is collected before the processing can begin. Let's focus on the high-level architecture on Kinesis data streams. The producers put the records data ingestion into the KDS. AWS provides Kinesis Producer Library (KPL) to simplify producers' application development and to achieve a high write throughput to a Kinesis data stream. A Kinesis data stream has a set of shards. Each shard has a sequence of data records. Data records are composed of the sequence number, a partition key, and a data blob up to 1 MB, which is an immutable sequence of bytes. The consumers get records from Kinesis data streams and process them. You can build your applications using either Kinesis Data Analytics, Kinesis API, or Kinesis Client Library, KCL. AWS KDS has the following benefits. It is fully managed and runs your streaming applications without requiring you to manage any infrastructure. It can handle any amount of streaming data and process data from hundreds of thousands of sources with very low latencies. KDS application can start consuming the data from the stream almost immediately after the data is ended. It can scale the stream up or down, so the data records never lost before they expire. The Kinesis Client Library enables fault-tolerant consumption of data from streams and provides scaling support for the KDS applications. Data can be secured at rest by using the server-side encryption and AWS KMS master keys on the sensitive data within the KDS. Access data privately via your AWS VPC. As a result, AWS KDS is massively scalable and durable, allowing rapid and continuous data intake and aggregation. However, there is a cost for fully managed service. We will talk about this in the pricing model. Now let's take a look at another AWS native service, AWS MSK, Managed Streaming for Apache Kafka. It is also a fully managed service that enables you to build and run applications that use Apache Kafka to process streaming data. It runs open source version of the Apache Kafka. It provides the control panel operations, such as those for creating, updating, and deleting clusters. It lets you to use the Apache Kafka data plane operations, such as those for the producing and consuming data, so you can lift and shift your existing applications, tooling, and plugin from the on-prem Apache Kafka into AWS without requiring changes to the application code. Let's take a look at AWS MSK's architecture. When creating an MSK cluster, you specify how many broker loads you want MSK to create in each availability zone. In the example cluster shown in this diagram, there's one broker per availability zone. Each availability zone has its own VPC sublet. MSK also creates the Apache ZoomKeep loads for you. Apache ZoomKeep manages the brokers, as I mentioned in the Apache Kafka's architecture. MSK lets you to use the Apache Kafka data plane operations to create topics, to produce, and the consume data. You can use the AWS Management Console, the AWS Command Line Interface CLI, or the APIs in the SDK to perform the control plane operations. For example, you can create or delete AWS MSK cluster, list all the clusters in the account, view the properties of the cluster, and update the number and type of brokers in a cluster. AWS MSK has the following key benefits. It is fully managed. It can create a fully managed Apache Kafka cluster or your own cluster using your own custom configuration. MSK automatically provisions, configures, and manages the operations of your Apache Kafka cluster and Apache Zonekeeper nodes. It has the high availability on the automatic recovery, patching, and data replication. From the security standpoint, it runs in the AWS VPC, data encrypt at rest using the AWS KMS with the custom master key CMK by default, or using your own CMK. It encrypts data in transit via the TLS between the brokers and between the clients and the brokers. SASL, SCRAM authentication secured by the AWS Secret Manager and the ACLs. AWS can handle the broker and the storage scaling. From an integration standpoint, it can integrate with AWS KMS, AWS Certification Manager, AWS VPC, AWS IAM, and AWS Glue Schema Registry. Now let's take a look at the Confluent platform. It is enterprise-wide the stream data platform. It leverages Application Kafka at its core. Confluent platform also includes a schema registry, a REST proxy, and integration with the Canvas, a MapReduce implementation that dramatically eases the continuous upload of the data into Hadoop clusters. It provides a fully managed service on AWS, Azure, and Google Cloud. Here are the key benefits of Confluent Cloud. It is serverless. It provides self-serve provisioning with no complex cluster sizing, zero downtime, Kafka upgrades, bug fixes, and elastic scaling between 0 and 100 Mbps. It supports hybrid and multi-cloud. It builds a persistent bridge from on-premise to cloud with a hybrid Kafka service, stream across public clouds for multi-cloud data pipelines. It offers high availability, guaranteed 99.95% uptime SLA, scaled to tens of the Gbps with dedicated capacity, achieve sub-30 millisecond latency at scale, and multi-AZ replication. It is highly secured with at-rest and in-transit data encryption, SAML SSO for user author N, Kafka ACLs for author Z, Zonekeeper secure by default, private networking via VPC peering or AWS Transit Gateway in the dedicated clusters, and monitoring the visibility with topic and cluster level metrics. It's centralizing Kafka management operations and simplifying Kafka troubleshootings are very impressive, such as the GUI-based Confluent Control Center, Confluent Replicator to manage replication of data and topic configuration between data centers, Confluent Auto Data Balances, monitoring and management reporters, etc. Both AWS MSK and Confluent Cloud are built on Apache Kafka, so I will compare the key concepts between Apache Kafka and Kinesis data streams. Apache Kafka uses partitions, and the AWS KDS uses shards in the data storage, so Apache Kafka's data ordering is in partition level, and AWS KDS data ordering is in the shard level. You can configure the data retention in Apache Kafka and AWS KDS. AWS KDS is improved its data retention up to 365 days with the extra charge. Apache Kafka's data size per blob is 1 megabyte by default, but it can be configured. AWS KDS maximum data size per blob is 1 megabyte. On partition shard modification, Apache Kafka increases only and does not repartition existing data. AWS KDS reshard by merging or splitting shards. There is no partition limitation on Apache Kafka. Optimal partitions depend on the user case. AWS KDS has the shard limitation as 500 shards in the US East, US West, and EU regions, 200 shards in all other regions. On data replication or DR, Apache Kafka can do cluster mirroring. AWS KDS will automatically cross 3 availability zones. On message delivery, Kafka guarantees at least once delivery by default. Kafka supports exactly once delivery in the Kafka streams. AWS KDS had at least once delivery. All solutions has very strong security features. Apache Kafka provides either SSL or SASL and authentication of connections to the Kafka brokers from the clients, authentication of a connection from brokers to Zoomkeeper, data encryption with SSL or TLS. Data in AWS KDS can be secured at rest by using server-side encryption, and AWS KMS master keys on sensitive data within the KDS, access data privately via the AWS VPC. Apache Kafka provides a YAML metrics for the metrics reporting in the server. Confluent Cloud provides more commercial monitoring and management. AWS uses CloudWatch and CloudTrail for the monitoring and auditing. On the dependency, Apache Kafka uses Zoomkeeper to manage the brokers. AWS KCL Kinesis Client Library uses a DynamoDB to track state info of the record processing. Before we take a look at each one's pricing model, I need to point out that I don't recommend running Apache Kafka on any public cloud provider computer engine, because it requires a lot of human support on the installation. Setup sometimes could take weeks. The difficulty on configuration and the cluster management. To easily compare the cost, I use the basic features in each solution. Let's take a look on AWS KDS pricing model. AWS KDS pricing is based on two core dimensions, shard hour and per payload unit, plus optional dimensions for enhanced fan-out, extended data retention, and long-term data retention. Let's estimate the cost from KDS pricing calculator. Let's use 50 records per second, 2 KB per record, 3 consumer apps, data retention up to 7 days, and 3 enhanced fan-out consumers. The total monthly estimated cost is $70.03. Let's take a look at AWS MSK's pricing model. You pay for the time your broker instance runs, the storage you use monthly, and the standard data transfer fees for data in and out of your cluster. From FSK pricing example 1, 2 Kafka T3 small instance in the US East region with 50 GB of storage brokers used for 31 days will cost you $72.85. Now let's move to the Confluent Cloud. Confluent Cloud offers 3 budget plans, basic, standard, and dedicated, plus the data transfer fees for data in and out, the charges on data storage and partitions. Click See Full Cluster feature and pricing details to review the details of each budget and each feature. Let's do the cost estimate from a Confluent Pricing Estimator. Let's select AWS and select the US East region with the basic single zone, 0.1 Mbps for read and write, 50 GB storage, 3 partitions. The total monthly estimated cost will be $81.93. Confluent offers $200 offer on each of your first 3 months' bills at the time of this video. The cost can end up very quickly with the standard multi-zone, data in and out capacity, data storage, or the total number of partitions. In general, Confluent Cloud will cost more than the other 2 solutions. Here's my conclusion. If you are using Apache Kafka in your on-prem, then do a trial on AWS MSK and Confluent Cloud. If AWS MSK can provide all your requirements, then using AWS MSK. It is cheaper than Confluent Cloud. However, if you are looking for an enterprise streaming platform, then choose Confluent Cloud. The Confluent platform is a foundational technology that makes it easy to build real-time data pipelines and streaming applications by integrating data from multiple sources and locations into a single central event streaming platform for your whole company. I like its centralized Kafka management operations and simplified Kafka troubleshooting. If you don't have any knowledge on Apache Kafka or already using other AWS services in your development, then you should consider AWS Kinesis data streams for any new real-time data streaming development. With the great integration of other AWS services such as KDF Kinesis Data Firehouse, KDA Kinesis Data Analytics, Athena, and Glue, etc. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.